Hey everyone, welcome. When you're designing systems, you need a tool that can do a bit of everything, kind of like a Swiss Army knife. Well, that's Redis for you. Today, we're going to dive into 5 battle-tested ways Redis tackles some of the toughest scaling problems you'll ever face. So let's jump right in and see how this thing works its magic. So let me just ask you this. What's the real secret to building an app that's not just okay, but one that's ultra fast? I mean, an app that can handle a massive flood of users without breaking a sweat. It's a huge challenge, right? And a massive part of that answer, well, it all comes down to how you handle your data. And that's where Redis comes into play. You see, at its heart, Redis is what we call an in-memory data store. And that phrase right there, in memory, that's the whole ballgame. It means Redis keeps all its data in your server's RAM, not on some slow spinning disk. Just think about it like this. It's the super fast, short-term memory for your app. Data access is practically instantaneous. That's the secret sauce to its legendary speed. Okay, so what's on the docket for today? We've got a quick intro to what Redis is, and then we're diving straight into 5 powerful use cases. We'll start with the big one, caching. Then we'll talk about sharing user sessions, locking down shared resources, limiting request rates, and we'll finish up with something fun, building super fast gaming leaderboards. All right, first up, we're talking about the number 1 most common, absolute biggest reason people start using Redis, caching. It's all about making your app faster. So let's paint a picture here, because I'm sure we've all felt this pain. Your app starts to get popular, right? More and more users are signing up, making requests, and every single one of those requests is just hammering your main database. Before you know it, that database is the bottleneck, and your whole app just slows to a crawl. It's a classic, and honestly, a super painful scaling problem. But the Redis solution is just beautifully simple. It acts like a middleman, sitting right between your app and your database. And what it does is it holds on to copies of the data that gets requested all the time, right there in that super fast RAM. So when a request comes in for that popular data, boom, Redis hands it right over, instantly. The database never even gets bothered. This takes a huge load off your database, and your app's response time just skyrockets. And what if you get really big? Well, you can use a technique called sharding to spread that cache out over a bunch of Redis servers. It basically becomes infinitely scalable. Okay, so we've seen how Redis can make things fast. Now let's tackle another super common headache, sharing user sessions. Making sure that when a user logs in, they stay logged in, no matter which of your servers they hit. It's a big deal in modern apps. And how it works is actually pretty clever and straightforward. So a user logs in. Instead of you storing that session info on one specific web server, which is a big no-no when you have more than one, you store it in Redis. You give it a unique session ID. Then you just send that ID back to the user's browser as a little cookie. Now, for every future request, it doesn't matter which of your servers get it. The server just grabs that ID from the cookie, asks Redis, hey, who's this? And Redis instantly provides all the session data. Simple. But wait, there's a catch, right? Since Redis is all in memory, what happens if that Redis server crashes or restarts? Poof! All your active user sessions are just gone. Now, you could use something like snapshotting, which saves the data to a disk, but reloading that data can take minutes. In a live app, that means kicking every single user out and making them log in again. Not good. That's why for this kind of thing, replication is the way to go. You have a backup Redis instance that's always getting a live copy of the data. If the main one goes down, the backup just takes over, like instantly. Your users, they never even notice a thing. All right, use case number 3. We're getting a little more advanced here, but this one is so important. We're talking about distributed locks. Think of it like a one-at-a-time please sign for your shared resources, preventing total chaos when everyone tries to grab the same thing at once. Just imagine this. 2 people are trying to book the very last seat on a flight, and they click buy at the exact same millisecond. What happens? Without a lock, your system might get confused and sell that one seat to both of them. That's called a race condition, and believe me, it can cause some serious headaches and very unhappy customers. So how does Redis solve this? With a really clever command called setNX. It's short for set if not exists. Here's how it plays out. Client 1 says, hey Redis, set NX on this airplane seat. Since nobody has that lock yet, Redis says, sure thing, returns a success, and client 1 officially has the lock. Milliseconds later, client 2 tries the same thing. But this time, Redis sees the lock already exists and says, nope, sorry, returning a failure. Client 2 has to wait. As soon as client 1 is done, they just delete the key and the lock is free for the next person. It's a super simple but incredibly powerful way to keep things orderly.
Okay, moving on to number 4, rate limiting. This is all about protecting your services. Think of it as a bouncer for your API, making sure no single user can overwhelm your system, whether they're doing it on purpose or by accident.
And with Redis, building a basic rate limiter is surprisingly easy. Here's the recipe. For every single request that comes in, you grab the user's ID or their IP address and use that as a key. Then, you use Redis's super fast increment command on that key. This just counts up their requests. You check the count. Is it under your limit, maybe 100 requests a minute? Great, let it through. Is it over? Sorry, you're cut off. The final crucial step is to tell Redis to automatically delete that key after, say, 60 seconds. That resets the counter for the next minute. It's an incredibly effective way to protect your app.
And now for our 5th and final use case, we're going to talk about something really fun, but also something that needs to be lightning fast, building real-time leaderboards for games.
So what's the magic here? Well, it all comes down to a special Redis data structure called a sorted set. Now, this isn't just your average list. It's a collection of unique items, like player names, where every single item also has a score. And here's the killer feature. Redis automatically keeps the entire set sorted by that score all the time. So why is this the perfect tool for the job? Well, think about it. Player names have to be unique. Check. The list is always sorted by score, so you never have to do slow, expensive sorting operations yourself. Double check. This means that asking for the top 10 players, or finding out where player X ranks, happens in what we call logarithmic time. Now, if you're not a developer, all you need to know is that means it's ridiculously fast. It doesn't matter if you have 100 players or 100 million. It just works, and it scales like a dream. So there you have it. We've gone from speeding up websites to managing user logins, preventing race conditions, protecting APIs, and building game leaderboards. It just goes to show how incredibly versatile Redis is. And honestly, these 5 examples, they're just scratching the surface. There's a great saying in the Redis community: our creativity is the limit. And it's true. Its basic building blocks are so powerful, you can really build almost anything you can dream up. And that brings us to the end of our tour. So I'm going to leave you with one final thought to chew on. Now that you've seen what this tool can do, what's a real-world problem you're facing, maybe at work, maybe in a side project, that you could solve with Redis? Give it some thought. Thanks so much for watching.